So we are going to now talk about a tour of a selected classifier and what it entails, where we look at an example of classification problem. So here we've talked about some of the procedures for a machine learning system. We have data, you have your data, so you do data exploration, exploring the data, visualizing the data, feature selection, feature extraction. So then here we are interested here, and we want to cover this part. So the learning process, supervised learning. So we want to look at the algorithm, how does it work, actually, yeah. The evaluation will come, so after you have trained your model. So in classification, generally, in this case, it's a data science task of predicting the value of a categorical variable. So by building a model based on one or more numerical or categorical variables. Now, so there are 4 main groups of classification algorithms. We have the frequency table-based algorithms, like the 0R, the 1R, the Neigbour and decision tree. We call them frequency table-based algorithm. You have to prepare a frequency table, just like you do in statistics. How many here, how many sample here, how many here, and then you solve it through that. Then we have the covariance matrix, like linear discriminant analysis, like logistic regression. Then we have the similarity function, like k-nearest neighbor, which is going to be the one we are going to discuss today briefly. And then we have others. Others means they are using totally different ideas, like neural network, support vector machine, and host of others that doesn't fall into this particular 3 categories. So as we've listed earlier, this is k-nearest neighbor, Neigbour, decision tree, support vector machine, artificial neural network, and host of others. How classification works. Let's pay attention to this. You have your classification algorithm. You have the training data given to you. This is a CS grade. This is the result. So you want to predict what is the result of this. This is the label. So you try to develop a classification model. When you train it, this is the hypothesis function generated now. This is the rule. I told you hypothesis function could be a rule. Very simple rule. So if CS is less than or equal to 5, then the result is going to fail. And if you check it here, any result that is less than 5 or equal to 5, there will be failure. This is pass. This is pass. This is how classification works. You study the variable. This is the feature. This is the feature, the variable. The independent variable. Why this is the result? The output or the dependent variable. How can this affect this? So we got to know that our model use this simple rule. So if you have fault today, you can pass, otherwise you fail. Then we brought in a test case. And I told you the test case must not be inside the training set. So the test case said CS is equal to 8. It means the grade was 8. Then you put it back into your model. This is the hypothesis function. This is the program generated by our system. If the grade, CS grade, which is 8, is less than or equal to 5. 8 is not less than or equal to 5. So if it is less than, it's going to fail. So it means the output is going to be pass. So this is the testing stage. After training, you use the training set to train your algorithm. It generates a model. Then the model is tested using unseen data. And you can see the outcome, pass. If I put 2 here, so let's say I put 1 here, 1 is going to become fail because this rule will say no, it doesn't pass. That's how classification works. Again, it could be a more complicated data set. You have a data set here. This is the training set and the testing set. So you have learning algorithm. It's like induction. I told you inductive learning hypothesis. Induction will generate the model. From the model, you can deduct back to generate the output, because here we know the input and the output. Now we generate a model from them. Now we don't know the output. We want to generate our output from the model. That is deduction from the model we detected. Now, so and classification, just like another system, has two steps. We have the model construction step, where you define the system, you train the system, and then you have the model usage for classifying future or unknown objects. This is where you're going to estimate unknown object or classify unknown objects. Several other examples could be given. This is a kind of a classification problem regarding, this is a kind of a professor. Yeah, here you have, name is professor. We want to determine who is a tenure professor. You see, the problem, we want to determine someone is a tenure professor or not. Name, rank, years. You have them as example. So you train your model to generate the rule. The rule is if rank, professor, or year is greater than 6, it's going to be yes. See, the system tries to study the data. This is not part of your data. Pay attention to this. This is a name. You don't use name for training, by the way. You see? You don't use it for training. It's just there to identify the samples. Sometimes we have seen people, they got data from the clinic and it has medical record number, and they use the medical record number to do the modeling. I said, no, you have done the wrong thing. You have to go back again and repeat your experiment, remove the medical record number, because that is not part of the attributes of a patient. That is just a dummy variable put there to identify the patient. So we pay attention to this when we have our data appropriately. Once we have trained our model and we generate that rule, then they give us test data. We can use it to check if a professor is tenure or is not tenure, as the case may be. That is how the system works. It could even be even more complicated system. They follow the same procedure. That is, you have the training set, you have standing, we have youth, we have low income. Based on your low income, we want to determine maybe you are going to have risky, are you having risky loan status or otherwise. You can see the rule is becoming complicated. So long, if age is youth, then loan decision is risky. If income is high, then loan decision is, so you have an hypothesis function that is represented by this system. This is how it works. And then you can do the testing to generate. Now, we say type of learners. We have eager learners and lazy learners. That is lazy algorithms and eager algorithms. The eager learners, they are going to really generate a new, totally new model from the system, like decision tree, Neigbour, artificial neural network. They can take time for the training, but the testing will become faster. But for lazy learners, like KNRS neighbors, the training data is stored. They use the training data to determine what's going to be your output when you bring in a new sample. They are characterized by fast training. They don't even do training, by the way, but very slow testing period. So they have their own advantage and disadvantages. But the good thing is it's very simple. It works for you when you have very simple data or very small data. Now, our friend, K-nearest neighbor. What is K-nearest neighbor? How do we choose the value of K? And then we have an example briefly. You see, K-nearest neighbor is one of the simplest supervised algorithms that are mostly used. Very simple. It classifies data point based on how its neighbors are classified. Like the name, K-nearest neighbor. Show it is simple summary I used to give it is, show me your neighbor, I will tell you the kind of person you are. If your neighbors are good, we select 7 of your neighbors at random, and 6 of them are good. There's very high possibility that you are good. That is the idea of K-nearest neighbor. When you have data set, it tries to look at data that are closer to what you are having, and then based on that, it will put you in the class that your neighbor belongs to. Majority of your neighbor, they put you in the class they belong. To do this, you know, we need to compare them. We are going to have a kind of comparison formula. See? So the K in KNN, K is the number of neighbors we are going to use. How many neighbors do we use? Is it only 3 neighbors or 4 neighbors or 7 neighbors? It depends on the problem we are solving. If you are solving classification problem, it's always good to use odd number of neighbors. K should be set to odd number. 1, 3, 5, 7. If our classification problem is binary classification. Because if you have 3 classes to classify and you set it to 3, then every one of them take 1, 1. There's not going to be clear majority because it's work on the principle of majority. Now, there are similarity measures that k nearest neighbor do use. See, we need to know that the Euclidean distance measure, Manhattan distance, and Minkowski distance, these are very popular. These are very popular measures. We should know that they are only valid for continuous variable. If the variables are continuous, we can use them. However, for categorical variable, the Hamming distance must be used. The Hamming distance must be used. Now, so this is the formula for the Hamming distance. So here you see the formula. You want to see the distance between one sample and the other. For example, you have sample 1. You see what is the distance between this sample and the other one. And we're going to have an example to demonstrate it. Why the Hamming distance is given like this. So in Hamming distance example is you don't have numbers, rather you have male or female, X and Y. Male is going to be 0 because there's this distance between them. If they are equal, D is 0. If they're not equal, it's going to be 1. That is the formula for Hamming distance measure in KNN. And there are other distance measure that you can use. Now, this is how KNN works. The first step is for you to calculate the distance. Calculate the distance between. Calculate the distance. Yeah, calculate the distance between the unknown case. You know, you have been given data set. You are given this data set. And this data set, they have been labeled for you. This belong to red class A, class A. Why this belong to class B? You can see the definition already. Now they now give you new one. This is testing it. Your training data is already given. They are labeled because this is supervised learning. But they don't give you a new sample. And they now ask you, where should we put it? Where does this sample belong to? We don't know. What do? You calculate the distance between this particular unknown sample. You might know the class, you keep it secretly to yourself because you are training a system. So you calculate the distance between this and every member of the training set. Everything. You store the distance. So we have distance between you and this. That's going to be like 8 and then 7. That's going to be like 15 distances. 1, 2, 3, 4, 5. You rank the distance. You find the closest neighbor. You see? Find the closest neighbors. Who are closest to this guy after the distance? Graphically, we can see it here. This one is closest. If we set our K to be equal to 1, you know, I told you K nearest neighbor means, K means how many neighbors do you want to check to take your decision. You see only 1? Okay, it means this guy will belong to class A. But if I want my neighbor to be maybe 3, like this example, I have 3 closest neighbor. Yeah. So we want to use 3 nearest neighbor as an example. So you look at what are the distances. This is the distance. This is the distance. This is the distance. So we select the 3 of them that are closest to this guy out of the 15 available samples. And we rank them. 2 of them belongs to class B. 1 belongs to class A. It means my neighbor is going to belong to class B. Majority carries the vote. That is K nearest neighbor. Okay. Now, so the algorithm works in this way. You choose K. The first thing is to select the value of K. For a given new instance, X new, you find K, which is closest training point at the distance, with respect to the distance measure. Then classify the new sample you don't know. based on the majority voting among the k points. So you select the three that are closest to it, and then choose the majority. There are two classes now. Two of them belongs to one class, and another one belongs to the other class. You say, okay, out of your 7 neighbors, 6 of them are good, only 1 is bad. Then that means you are a good guy. But in another case, 6 of them are bad, and only 1 is good. We can understand the implication of that. That is k nearest neighbor in action. So how do you choose the value of k? My advice, there are a lot of advices, but my suggestion is always that we should follow the principle of let the data speak. Let the data speak. So also, always use your k by letting your data guide you. You have the training data there. So try to optimize your parameter. Search for the best parameter. You know, k can be 1. For 2 class problem, k could be 1. It could be 3. It could be 5. Use 1, run the experiment, see what you get. Use 3, run the experiment, see what you get. Use 5. You keep using different value of k. This is called optimization, by the way. You see, when people hear of optimization, it is something so complicated. That is a simple optimization of your algorithm. You don't just run KNN by using k is equal to 1 and you report it. This is my work. It's unacceptable. You are not fair to that algorithm. You need to be fair to it. You need to exhaust the possibility that there are still some values you didn't consider, and they could give you the best results. So I've seen people comparing 2 algorithms. One of them was optimized. The second was not optimized. This is unacceptable. You have to optimize them by trying to search for the best value of their parameters before you take a decision. The 2 parameters for k nearest neighbors include the k, the value of k, how many neighbors you want to use, and then the distance measure. Are you using Minkowski? Are you going to use Manhattan distance, or what other distance are you using? Now, there are some 3 tips. They say choose odd k for 2 class problem. I've clarified that. And k must not be a multiple number of classes. If you have 3 classes, you cannot use k to be 3, because that is going to be a confusion. You see, the number of k cannot be equal to the number of classes, and that's why you cannot use 2 for 2 class problem, because there's going to be a tie when you want to take the decision. Now, so the main drawback or challenges of k nearest neighbor is the complexity in searching the nearest neighbor for each sample. You see, because every time you have a new sample, you have to calculate the distance between that sample and all the training set. And imagine that you are having 200 samples and you want to test all these 200 samples. You are going to calculate distance for each sample, and the training set, you repeat it 200 times. You are going to arrange them in ascending order and then select the best 3 or 4, 5 or 7, as the case may be. It could be time consuming during testing. Now, let's look at a very simple example. Let's pay attention. And then we move to the demonstration using Weka. Now, consider a data set having 2 variables, math grade, CS grade, and each point is classified as pass or fail. This is math grade. This is CS grade. Now we want to use k nearest neighbor to solve this problem. How do we do it? The first thing is you need to this has been given to you. Now, this is the testing set. This is the training set. Training set, they gave you that this one failed. Somebody got 4, got 3 in CS, got 4 in math, he failed. This one got 6, 7 here, if passed. 7, 8, pass. This is the training set. Training set. And this is the testing set. This one is the testing set. This only one. Because the one that was not, testing set must not be in the training set. Let us get that. Sorry, yeah. Testing set must not be in the training set. And that's what we defined for us mathematically earlier. So based on the given data, we must classify the unknown as pass or fail using KNN. Now, how do we do? You find the distance. You calculate the distance between this person and the test set. Let's pay attention. What is the distance between this person and this person and this guy? This one is 4, this one is 6. You have to bring in, let's say we're going to use Euclidean distance. Let's remind ourselves about the distance. This is the formula of Euclidean distance. You can see. See, it's going to be xi. So xi Si minus yi. You see? So when you go back here, you're going to see that if you try to subtract, you are trying to say 6 minus 4. And this case might be 6 minus 4. 6 minus 4, which is what? Which is 2. You have it here. You have it here. And then this one, 8 minus 3. You treat it there. You treat this one and this one. This is the distance we got. Using that formula. Because of time, I want us, you can double check that one later. You compare this one again with this sample. Use that formula to calculate the distance. This one and this one. You see that this one is going to give you 0. Then you're going to have 7 minus 8, 1. It's going to be 1. That's why you have 1 here. 7 and 8, compare it to this. Do that for all this stuff, then this is what we have. Now arrange them in ascending order. Which ones are closer to this guy? Which one is closer here? Is it 5 closer to this guy? No. The shorter the distance, the more closer it is. So this is number 1 that is closer. The second one is closer. 2 is also closer. This is 3. Sorry, 1, 2, number 3, number 4, number 5. And we are using our K to be 3. You select the 3 that are closest to it. And that is going to be this one, and this one. These ones are out. They are far away because we are using K nearest neighbor. K to be equal to 3. Now you have to decide what is going to be the class of this new sample. Okay. What is the class of this one? Pass. Pass is 1. You vote. We are voting now. We have a ballot box. Fail. For this one, it is pass. So 1 is here already. This one also pass. This one becomes another 1. 2 pass. Wow. It means all the neighbors that are closest to it, they pass. Therefore, the class for this one is going to be what? Pass. This is what we call K nearest neighbor. See, so we calculate the distance, select the number of K you want to use, and then solve your problem. We decided to go through the procedure. You can see the way it happens. I know some people don't like mathematics, might be already bored, but let me tell you the good news. You don't need to know how to do this mathematics, by the way. The software will do it for you. And this is what we want to demonstrate now. You see, you just need to open your software, open your Weka, open K nearest neighbor, put in your data, and you start solving your problem. But at least we demonstrated so that you can know the way it works. This is an activity for you later. I will share this slide with you. Try to solve this problem by yourself. But then this is this person, this is the weight, this is the height, this is the class categorization. Underweight, normal, underweight, normal. Is this person normal or underweight? Choose different value of K is equal to 3, K is equal to 1, K is equal to 5, and solve using KNN. This is how KNN works, and host of other things that we have. Like the major process of KNN is very simple, like I told you, very simple, easy to understand what is going on, because sometimes we want our client to understand what we are doing. They want an explanation. So you use K nearest neighbor or decision tree that can easily be explained to them. So now permit me now to switch to the Weka environment so that we can demonstrate.